I'm about to show you why using L'Hopital's rule to solve this problem is a big mistake. One that I used to actually make, in fact. But you know what? Today you've become a number ninja because you've smashed that subscribe button, and you're not going to be making these kind of mistakes on your AP exam moving forward. So let's go ahead and dive into why we can't use the rule here. This limit comes from the squeeze theorem, if you remember. And if you don't, you can always check out the YouTube videos on that. But basically what happens here is that when you plug in x equals 0 for both sine of x and the denominator of x, you'll notice that you'll have sine of 0 over 0, and this will result in trying to divide by 0, which isn't allowed. And if you remember with L'Hopital's rule, because you're in a situation here where you have 0 divided by 0, this is one of the indeterminate cases where you're allowed to normally use L'Hopital's rule. And what does that rule say? Well, I've got a video you can check out on that, but basically what it's saying is, in the cases only where when you plug in the value you're approaching, if you end up with an indeterminate form, then you can take the original limit and basically say it's the same as taking the limit as x approaches 0, but this time of the numerator's derivative divided by the denominator's derivative. So because we have sine of x divided by x here, what we can actually do then is, separately for the numerator and the denominator, we start out by taking their derivatives. So sine of x's derivative is cosine of x. And then for the denominator, the derivative of x is 1. And so when you plug in 0 for x, you would get cosine of 0 divided by 1, which is 1 over 1. And that is the correct answer for this limit. And this limit actually comes from squeeze theorem. But should we really be using L'Hopital's rule here? There's really only one reason you should, and you're going to want to stick around to see why that it's the case. But let me show you, generally speaking, why this is technically not allowed. So the problem here is you're using circular reasoning and a definition of something towards solving that same something. And what I mean is, first of all, the way we use L'Hopital's rule here already assumes that we know that the derivative of sine of x is cosine of x. So let's just say we were a new student, a new baby ninja, and we're like, I want to find out what the derivative of sine of x is. I'm going to use the first principle. Okay, so we can set f of x, that function, to be sine of x. And instead of using memory to say that we already know that sine of x's derivative is cosine of x, we're going to formally use the first principle here. And you probably remember this from Calc 1. Basically, anywhere you see x, for the first term of sine of x here, you're going to plug in this x plus h, because for the first principle, the derivative of f of x is the same as f of x plus h minus f of x all over h. Okay, well, this seems fine so far. Nothing's really breaking any rules, right? Well, we have an identity to use here. We have this sine of x plus h term. And using that trig identity, this limit becomes the expansion of that first term, which is going to be sine of x cosine of h plus sine of h cosine of x. Keep in mind, those are not the hyperbolic functions. I just happened to use the letter h here for my variable. All minus sine of x all over h. Now, we can take this one step further. Because this is a limit expression using h as the control variable here, whenever you see an x, we can actually treat those terms as constants. Meaning, if you remember with the limit, constants can be brought out. So for example, the limit as x approaches 0 of 3x would be the same as bringing that 3 out, and you get 3 times the limit as x approaches 0 of x. And so it's a similar idea here. I'm going to go ahead for each of these terms, and I'm going to bring out the x terms because they're treated as constants here. And we're also using the idea that with limit expressions, if I have a limit of a fraction of sums or differences, it's the same as separating out the limits into separate ones, right? By breaking up the fraction. And we're going to do that here. So now we have 3 different terms. And for each one, you'll notice that the x term is brought out because it's basically treated as a constant. But look at this particular term here, cosine of x times the limit as h approaches 0 of sine of h over h. Now that's the problem, right? We're basically here in kind of a loop. We started with this as the original problem to solve, right? The limit as x approaches 0 of sine of x over h, or sorry, I should say x. And here we're just calling it h. Okay, but it's the same idea. It's circular reasoning. Now, I did say earlier that there's really only one case where using L'Hopital's rule is okay. And this is basically saying Once you can actually use the squeeze theorem properly and understand it and know how to solve this limit without using L'Hopital's rule, then moving forward, go ahead and use it as a shorthand.